Hey guys, welcome back. This is the last video for Unit 11, Solution Chemistry. We're going to talk about molarity. Molarity is simply the measure of the amount of solute in a given amount of solvent or solution. So basically what we're looking at is how concentrated a solution is. The more solute you have, the more concentrated it will be. The less solute you have, the less concentrated it will be. Pretty self-explanatory there. You have this formula in your formula chart. Molarity equals the amount of solute in moles divided by the volume of solution in liters. So you've got to keep those units in mind. So you're looking for moles of solute and liters of solution. If you're given any other values, you're going to have to do some stoichiometry to figure that out. So things to keep in mind as you're looking at these problems: as you increase molarity, the solution is more concentrated. Higher the molarity, higher the concentration of solute. Low molarity means you have a dilute solution, and a high molarity means you have a concentrated solution. So if you're in the lab and you're dealing with a 0.02 molar solution, it's a very low concentration, so it's going to have a low molarity. Okay, if you're dealing with 13 molar solution, then now you're dealing with a higher concentrated solution, a higher concentration of solute. Okay, now we simply need to be able to use this formula to solve these problems. And we've got 3 examples in your notes. The first example, you're asked, what is the molarity of a solution that contains 1.5 moles of sodium chloride in 3.5 liters of solution? So remember, molarity equals moles over liters. In this particular problem, I'm given 1.54 moles of sodium chloride, and I'm told that that is all in 3.5 liters of solution. So 1.54 moles divided by 3.5 liters gives me a molarity of 0.44 molal. So capital M is my unit. That is your first example. Remember, moles over liters. Second example, how many moles of hydrochloric acid are required to prepare 0.8 liters of a 0.5 molar hydrochloric solution? So in this problem, again, we're using the same formula, moles over liters. Okay, but in this particular problem, I'm given the molarity, which is 0.5, and I'm trying to figure out how many moles of hydrogen chloride I need to put in this solution to create that molarity. So if I have 0.8 liters and a 0.5 molar solution, I can simply cross multiply there. So 0.5 times 0.8, which will give me 0.4 moles of HCl. That's how much I need in order to create that particular concentration of solution. Okay. Last example. I'm going to erase this so we have some room to work with. Keep in mind, same formula we're going to use for each of these problems. Same formula, moles over liters. Moles over liters of solution. So last example there. If 35.8 grams of lithium hydroxide are dissolved in enough water to make 750 milliliters of solution, what is the molar concentration or molarity of that solution? So we've got to wade through this information here, figure out what we need. Remember, molarity equals moles over liters of solution. In this particular problem, I'm given 35.8 grams of lithium hydroxide. So that is the substance that's being dissolved in solution. I've got to figure out not how many grams of lithium hydroxide I have, but how many moles. That's the amount I'm looking for. So using stoichiometry and dimensional analysis, I can figure out one lithium atom, one oxygen atom, and one hydrogen atom. Find the mass of all of those. Lithium is 6.94, oxygen is 16, hydrogen is 1.01. Add all of that together, that gives me a mass of 23.95. So if I had 1 mole of lithium hydroxide, it would have that mass. So there's my stoichiometry. 35.8 grams divided by 23.95 will give me the number of moles that I have. If I do the math there, I have 1.49 moles of lithium hydroxide. Great. I'm told that that is the amount of lithium hydroxide I have in 750 milliliters. Remember, I don't need milliliters, I need liters. Remember, for every 1,000 milliliters, that's 1 liter. So 750 milliliters divided by 1,000 will give me 0.750 liters. So now I have liters of solution and I have moles of solute. I can figure out molarity. So I take the 1.49 moles of lithium hydroxide. Remember, that's what we got right here with my stoichiometry. And I have the volume, which is 0.750. And if I do the math there, I come up with 1.99 molal. So that is my molarity, 1.99, capital M. Pretty straightforward. It's just a matter of finding what you're given in the problem and then solving for your unknown. Always remember, you got to have moles of solute and liters of solution in order to find molarity. Hopefully this will give you some practice to work forward, and I will see you in class next time.